All right, so hello everyone, and welcome to my talk, which is called How Writing Just One Import the Wrong Way Slows Down Your Website. I hope you had a great Workdays Ticino so far. And let me first introduce myself. So my name is François, and I'm a senior full-stack software engineer, and I work at the company Karakun, and we have offices in Dortmund and Germany and Basel, so in Switzerland and Germany as well. And I'm also an active member of the Swiss Testing Board, which is a member board of the ISTQB, which is doing testing certifications in software testing. And I'm also in the advanced and expert level working group at the ISTQB itself. By the way, maybe you've noticed there's a QR code on the top right. It will be on every slide, so don't panic. If you scan it, you can get the slides and also the recording sent to your email. So, if you want to watch it again later at some point, you can do that. So I remember when I was young, my mother told me that money doesn't grow on trees. Well, thankfully, ChatGPT allows us to generate images like this. And this kind of makes me question, was what I learned, correct or not? And, maybe money does grow on trees after all. Maybe we just need to shake them. Well, my talk isn't really about actual shaking of trees, but it's about tree shaking. But before we get into that, let me show you some basics just to level the playing field here. So to explain to you some terminology, which is in this case bundler or what a bundle is. So let's imagine you're doing a React application. You will typically have a package.json file that looks something like this. And then the webpack here that you can see is the bundler. Sometimes there are other bundles as well, or sometimes if you use Next.js, for example, Next.js will do the bundling for you in the background, or if you use Create React App, it also uses Webpack in the background to do the bundling. And what happens in the bundling is it takes those dependencies that you can see here, so React, React DOM, and Lodash, for example, in this case, and then this kind of splits it up into two different files. One of them is an index.html file, which is almost empty except for having the different script tags in it where it loads the JavaScript that you have. And then, just in a simplified manner, there's like, let's say, a bundle.js file. You can also split this up into multiple smaller JavaScript files. But just in this example, we have, in a simplified way, just one JavaScript file. And then what the index.html file does is, as I mentioned, it just loads the bundle.js file, and this then builds up the entire application when you go to the website. So it might look something like this. The body just references the script with the bundle.js file, and this includes all of the source code that you have and the dependencies that you have. So Webpack essentially takes all of those dependencies, turns them into two files, the index.html and the bundle.js, together with your source code. And again, in a simplified way, those of you that already know what tree shaking is, ignore it for a moment. But consider you have those two dependencies here, React and React DOM. Then, let's say the index.html file usually loads pretty quickly. 1 second is maybe a bit much, but let's imagine it loads in 1 second. Then afterwards it loads the bundle.js file, which, since you don't have that many dependencies, it doesn't take too much time to load as well, maybe 1 second. And now let's say you have a ton of dependencies in your package.json file. The bundler needs to include much more dependencies into your bundle, especially if you take in the whole internet. Then you have a lot more dependencies, and then this takes a lot longer to load. So you can see, in general, you can say if we ignore tree shaking, then it will take longer to load your application or your website, the more dependencies that you have, because the file gets bigger and this takes longer to load. And then let's look at an example of how tree shaking works. So here you can see some simple code on the left. You can see a function which is called shakeIt. And you have 3 different methods that we use from Lodash here. Essentially, what you can imagine is tree shaking works just as if you have a tree with all of the different functions that Lodash has, in the branches and in the leaves. And imagine it just like that, that all of the ones that are in leaves are the ones that we use in our code. So we use here, for example, a string, use isArray, and we use join. And these are the three leaves you can see on the right. And these, if we now shake the tree, fall down, that we don't use because they're not really strongly connected to it. And the ones that we use, they are still strongly connected. They stay on the tree when you shake it. So essentially, this way we kind of get rid of the methods that we don't use from the dependency, and this way we can make our bundle smaller because it just needs the size that you have for the isString, isArray, and join methods. So by definition, tree shaking is some form of dead code elimination, and it relies on the static structure of the ES 2015 module syntax, so for the imports and exports. And this name and concept was popularized by Rollup, which is not used that much anymore. At least I don't know how many of you who knows Rollup still. Yeah, okay, not that many, just one person. So I'm not surprised. That don't worry about it at all. So this was the post that originally was made, where tree shaking was introduced into Rollup. So you can see it was quite a long time ago, 2015. And also it has been supported by Webpack since version 2, which was in 2016. So it's a feature which has been included for a very long time. So now that you know what tree shaking is, the question is, if you have a software project that you're working on, you have a website, and you want to add Lodash as a dependency, is that a good idea? Well, there's a website which you can see on the left. It is called Bundlephobia, which shows you how big a file is that you want to include in a dependency is that you want to include into your dependencies. You can see here, for example, Lodash has a minified size of around 70 kilobytes. So it's quite a large libraries. If you gzip it, then it's a bit smaller, but still 24.4 kilobytes is quite big. And if you look at Vue, for example, just to compare it to see how big it is, you can see it's over half of the size of Vue. So Lodash in itself is quite big, even if you wouldn't think about it, with 40.7 kilobytes. So I was exactly in this situation a few years ago in a customer project that I've been in, and I wanted to use a method from Lodash, but we didn't have the dependency yet, and I just needed one method from it. So I was kind of wondering, does it make sense to add it? I did know about tree shaking, but I just wanted to make sure. And the answer is yes, if you do it correctly, then they can be tree shaken, which this talk is all about. So most advice you can see online around tree shaking, and which was what I have known before, my custom project before I, had an epiphany I will tell you about in a second. What I knew back then was, what was the advice that I learned from, what I saw online, which was use ES 2015 style imports and exports, and then you will be fine. It will be tree shaken properly. So in essence, this says that you shouldn't use these kinds of imports, which are CommonJS imports and exports. And this is another CommonJS way of importing it. And no, sorry, this is not the CommonJS one. This is an ES 2015. But if the foo file has more methods than just foo, they will be imported as well if you do it this way, even if you don't use them. So this is something to pay attention to. So this is what the internet tells you that is, the best way to do in most ways. To use these kinds of imports and exports, and then you will be fine. And then, there's just one thing. If you keep something in mind for, if you want to just remember one thing of this presentation, remember to never import a dependency like this, as you can see here. If you do this, this will include everything from Lodash into your bundle. This cannot be tree shaken if you do it like this. So now let's see. As I mentioned, I want to add Lodash to a customer project. And now I want to use the isString method from Lodash. And I kind of knew that my colleagues at the project, they were really wary about those kinds of things. And they they didn't like adding new dependencies that easily. So I wanted to make sure that, adding isString from Lodash didn't increase the bundle size too much. And so what I did was I measured the bundle size before I, added Lodash, and then I measured it after adding Lodash. So you can see this was the bundle size that I had before. And I used this import here, which follows the best practices according to the slide previous that we have seen. And after it, suddenly I noticed, wait, why does it add 24 kilobytes to my bundle? This doesn't make sense. Maybe if you remember the number from the last slides, Lodash has a size of 24 kilobytes. So this really included Lodash into my bundle. And I was really surprised about that. I didn't really expect that at all. And I don't know if you know about the Dunning-Kruger effect. This is kind of a principle where, as soon as you learn a little bit, you will become very confident. And then at some point, you notice that, you don't know everything, or you notice how much you don't know. And then you kind of dip down in this curve. And this area on the top, where you see this 100% on the left, this is called Mount Stupid. And I was kind of here at that point at the customer project about what I knew about tree shaking. So let me tell you what the internet doesn't tell you about tree shaking. So looking at the implementation of Lodash's isString method, this is how it looks like. And we can see it uses the old CommonJS style exports here, which I mentioned cannot be tree shaken. But that's not really all. What's worse is that it turns out that when you use 2015 imports together with CommonJS exports, then this results in the whole module being imported instead. And you don't get any warnings by the IDE, no warnings by the linter, no warnings by the bundler, nowhere. This just happens. So, what? So how can we still make use of tree shaking here? One approach you shouldn't take is just, copying the implementation of isString to your code base. And Lodash is actually structured in a way that it uses one file per method that it has, which is called the cherry picking syntax. So this allows you to write an import like this. So you can see if you write an import like this, where you write Lodash/isString, then it will only add 0.21 kilobytes to your bundle, as I measured. So, this really results in a negligible increase in the bundle size. Then there's a different way you can do it, which is you can use a package which is called Lodash-ES, which essentially is the same as Lodash, but it includes all of the ES 2015 exports. And this way you can use it just the way that you're used to with ES 2015, imports. Now you must be thinking, there must be an easier way. Do I really have to check every dependency and look at their code to see what kind of exports they use so that I know how to import it properly? Well, there is actually an easier way. So one example is there is an import cost plugin, which is available for both IntelliJ and VS Code, for example. And this helps you estimate the bundle size impact that you have with imports. So as you can see here, if we use the import I showed you that is good, it says 2.15 kilobytes. And if I change it to the ES 2015 import, it says 72.94 kilobytes. So it displays to you quite easily how much it uses. Of course, you still need to know what kind of imports and how you write the imports and exports. And you need to maybe try around a little bit to find the right one. But at least you can see the impact of what you add. And also, this is a useful tool in general, just so you know, even if it is tree shakeable, how much of an impact this has on your bundle size. So you can be more mindful with what dependencies you choose. And so this is one thing I would recommend. And again, so if you scan the QR code and get the slides, IntelliJ and VS Code is underlined. You can simply click it, and then it will go to the plugin. You can just download it this way. And then there's another way, if you don't want to use a plugin or you use an IDE that isn't available, you can use, for example, Bundlephobia, which is a website. And again, if you get the slides, you can simply click on the images, and then it will lead you to the Bundlephobia website. And you can see on the left, it shows tree shakeable for Lodash and for Lodash-ES and for Lodash. it shows you that it doesn't have this tree shakeable flag. So if you see this tree shakeable flag, you know that you can use ES 2015 style imports. And if it doesn't have this flag, then you need to be more careful. Maybe check if there's a cherry picking syntax, as there is with Lodash, for example. So it is time to create a pull request at my customer's project. And armed with the knowledge I gained, I created a pull request, including the dependency, because I was confident that it wouldn't add too much to the bundle. And this was the moment when I realized that I do know my colleagues at the customer project really well, because this was the comment I got on the pull request. Sure, you want to introduce Lodash just because of is string? That's a big fish. Yeah, so it is kind of difficult to predict by eye how and if bundles will tree shake without using a plugin or without looking up the code. And if you use a plugin like the import cost plugin or Bundlephobia, this can help you make decisions quicker than looking up the code and then see what imports there are. But as with performance optimizations in general, just like I did now with, in my case, you need to make sure that you measure, because only then you know what kind of impact you have. And my message is kind of, don't be afraid to use dependencies, but if you use dependencies, then make sure that they can be tree shaken. And also consider submitting a pull request to dependency if it is open source, if it is not tree shakeable, for example. Maybe they're happy for you to add it. So to come back to the image, maybe money does grow on trees after all. Because if we implement tree shaking in our applications, then the websites will load faster, and this makes our customers happy and our users happy as well. And this means we earn more money. So yeah, thanks a lot for your attention. Are there any questions? Yeah. Thank you so much. Yes. Yeah.
Which we can do things like, there are already things for similar things for Java related.
Okay. Yeah, so that's a good question. So actually there isn't, but there isn't really a reason for it, because with Java, for example, usually you run it on a server and you don't send the entire code of your application to the client. So you don't have this advantage that you need to make sure that your code is as small as possible so that you don't ship as much, that you don't ship too much stuff to the front end. And this way, you don't really need to do it, which is why it doesn't really exist. So in essence, you don't really need to, of course, if you have a REST API, you need to make sure that it doesn't return, too big things, of course, for example. But that's something that's much more difficult to control, of course. Yeah. Does that answer your question? I mean, of course, if you would use Timely for something like that, then this could be a problem. But then, usually you don't build too big apps if you have Timely for, some other HTML rendering engine on Java. Yeah. Oh.
Transitive dependencies? You were asking, Paco, maybe?
Yeah, but doesn't the compiler already fix this, or no?
Not really. Probably you inherit too much. Maybe it's something.
I mean, it could be something
to
fix. Yeah, to fix kind of the resolution of dependencies. That would be something. Yeah, but this would be in a different area. It wouldn't be to help with the performance or reduce the impact. But yeah, it would be helping a lot with being able to upgrade, for example, separate libraries, especially with Jakarta and Java X, right? Everybody knows this. It would be great. I don't know if there is something like that. I don't think so, but. If one of you knows something like this, feel free to let me know. But yeah. All right. There's one more question.
Have you had similar experiences with other libraries other than Lodash for these imports?
Yes, I did. I mean, I think I just picked here Lodash as an example because it's well known and it's a very big library, which where it makes sense to tree shake it. Most libraries nowadays, especially the modern ones, they use tree shaking already out of the box. It is kind of more rare to have to have a case like with Lodash here, where you need to use cherry picking syntax or use the other package. But still, you should check it to make sure. But most of them, thankfully, today are tree shakeable. Yeah. Thanks for the question. Right, so if you have any more questions, then feel free to hit me up, just in the hallway or something like that. And thanks to every one of you for coming here.